Hello and welcome to Dakota Prep's tutorial for sizing conductors that are supplying multiple motors. Now, in this case, we know that the rules for sizing conductors for motors are going to be found in Part 2 of Article 430, right? Specifically, for multiple motors, Section 430.24, okay? Now, if we're going to look at this question here to tackle this problem. It says, what are the minimum size THWN copper conductors permitted where two 10 horsepower, 3-phase, 460 volt design B squirrel cage motors and one 5-horse 3-phase squirrel cage, all the things, are all supplied by the same feeder circuit. Okay, so what this 430.24 tells us is, there's actually 4 rules, right? It's a sum of 4 different things. It says your conductor ampacity shall not be less than, it's got to be at least as large as or greater than the sum, okay, so we're adding, of, first of all, the largest full load motor, the big motor, full load current times 125%. So we need 125% of the biggest motor. Now we've got 2 other motors here. So in this case, plus the full load current of motor number 2, plus the full load current of motor number 3. Now, we don't have anything else. We don't have any other loads. We don't have any continuous or non-continuous loads, so we can ignore those, okay? We just need to plug in what we do have, right? The full load current for our motors into this formula here. So let's clean this up and go ahead and find our answers, right? So for our first motor, first of all, since we have, our biggest motor is one of 2 motors, right? It says we have 2 10 horsepower 3-phase motors. Well, we don't have to find 125% of both of those. It just says that 125% of the largest motor. So we just choose one. Since those are our largest motors, we just choose one. One of those 10 horse has to be sized at 125%. So let's go ahead and find that full load current. So we got to go to our favorite table here, table 430.250. This is for 3-phase motors, right? It's full load current, not nameplate value. So we go to 460 volts, 10 horse. That gives us 14 amps. That is our full load current for these 10 horsepower motors. So our conductor ampacity has to be larger than or equal to our largest motor, which is 14 amps, times 125%. So 14 times 1.25 or 125% equals 17.5 amps. Now we just need to add in our other 2 conductors, right? Our full load currents, that is, to size our conductor. So we know now that our other 10 horsepower motor has a full load current of 14 amps. Now we need to find our full load current for our 5 horsepower motor. So we go back to table 430.250. We find 5 horsepower, 460 volt for 3-phase, that's 7.6 amps. So we need to add that full load current in as well. Plus 7.6 amps, and then just find the sum of all these. So our conductor ampacity has to be greater than or equal to 39.1 amps. Okay, so we need a THWN copper conductor. Well, we need 3 of them, actually, all right? It's a 3-phase motor that can handle 39.1 amps. So now it's time to go look at the famous table 310.16, THWN 75-degree column. Hey, we need conductors that can handle 39 amps. We cruise down the column. Oh, 35 won't quite get it done. Number 10 looks like number 8 it is. Number 8 are what we need for all 3 of these motors. All right. Now that's a little confusing sometimes, because likely what's going to happen is that breaker that's out in front, that's protecting these conductors, it's not actually protecting them. It just seems like it is. It's just for short circuit current. We talked about that before. These conductors are likely to have an ampacity smaller than the breaker or fuse that's out in front, completely legal, completely fine. Remember, that breaker is only there, or fuse is only there for short circuit protection. Number 8. That's our correct answer.